Students, this is Dr. Anita Raj, your chemistry mentor, welcoming you for another session in Group 15. In this session, I shall explain you the anomalous behavior of nitrogen, especially why nitrogen does not have pentavalency and why it is not showing catenation and why it exists as diatomic molecule. Okay, so we shall move into the topic, students. See, actually, if you want to know the anomalous behavior of nitrogen, we should know that certain reasons are responsible for this anomalous behavior. That is basic reasons. The first one is the smaller size of nitrogen. Next one is it has high ionization energy. It has high electronegativity, and also there is a non-availability of d orbitals in nitrogen. Okay. So what about the smaller size of nitrogen? Actually, this is nitrogen. Its atomic number is 7. Okay. So when compared to other elements like phosphorus, arsenic, bismuth, antimony, see this nitrogen is having very smaller size. Okay. So since it is having very smaller size, its ionization energy is high and its electronegativity is also high. These points are interrelated. The ionization energy and electronegativity are interrelated with this smaller size of nitrogen. Okay. So what do you mean by ionization energy? Actually, it is the energy required to remove the valence electrons. Okay. See, this is the valence shell. That is the outermost orbit. Okay. So the electrons that are present in the outermost orbit or the valence shell has to be removed. See, if the size of the nitrogen is very small, okay. See, we need enormous amount of energy. We need more amount of energy to remove this valence electron. You know the reason why? Because in the case of nitrogen, the atomic size is very small when compared to other elements. So the nuclear pull, okay, so the nucleus which is here will be pulling the valence electrons towards itself, okay. So it will be pulling the valence electrons towards itself. So automatically what happens as great attraction will be there between the electrons and the nucleus. So that we have to spend more amount of energy to remove the valence electrons from nitrogen. Understood? That's why this nitrogen is having high ionization energy. Okay, now coming to the next point, why high electronegativity? The reason is what is the electronegativity? It is the ability to drag the pair of electrons towards the nucleus. It is the ability to drag the pair of electrons towards itself. Obviously, as I explained earlier, since nitrogen is very small in size, the nucleus which is present at the it can attract or it can easily drag or it can easily pull the valence pair of electrons that are present in the outermost orbit. Understood? So automatically the electronegativity of nitrogen is very high when compared to the other elements, because other elements they will be having very bigger size. Okay, since the atomic number is going on increasing down the group. Okay, let me explain what are the elements present in nitrogen family. That is group 15 nitrogen, phosphorus, arsenic, antimony, and bismuth. Is it not? So when you move down the group, the atomic number increases. When atomic number increases, atomic size increases. Okay. When atomic size increases, what happens? The pull of this nucleus on this outermost electron will be decreasing. Understood? Because the distance increases, so automatically it decreases. So what happens? Electronegativity decreases as we move down the group. So this nitrogen is having the highest electronegativity. Understood, students? And the next one is the non-availability of d orbitals. See, this is nitrogen. See the electronic configuration of nitrogen 1s2, 2s2, 2p3. It's not 1s2, 2s2, 2p3. And this nitrogen don't have d orbitals. Okay, this nitrogen don't have d orbitals. But when you are taking into phosphorus, it has d orbital, but it is an empty d orbital. Though it is empty, it is having d orbitals. Okay, and obviously arsenic, antimony, and bismuth, all these are having d orbitals. So since because this nitrogen is not having d orbitals, that's one of the main reasons for the anomalous behavior of nitrogen. Now we shall see why this nitrogen is not showing pentavalency, why it is existing as diatomic molecule, and why it is not having a tendency towards catenation. Understood? So the next important point is the anomalous behavior is why nitrogen exists as diatomic, whereas other molecules or other elements does not exist as diatomic molecule. Because see here, this nitrogen has an unique ability to form p pi multiple bond. Okay, p pi multiple bond. Okay, so it forms p pi multiple bond. Which one? A nitrogen. Okay, whereas other elements it's not possible to form an effective p pi multiple bond. The reason is the size. The size of nitrogen is smaller. Okay, so since the size of the nitrogen is smaller, the p orbitals of nitrogen can easily overlap effectively. See, the p orbitals of nitrogen can easily overlap. It can easily overlap. Understood? The p orbitals can easily overlap because of the smaller size. Okay, whereas in the case of other elements like phosphorus, arsenic, antimony and bismuth, since the sizes or size of these elements are going on increasing, these heavier elements of this group do not form this p pi multiple bond because their atomic orbitals of these heavier elements are too large. They are very large. Okay, the atomic orbitals of these higher elements or heavier elements are too large, so that and of course they are diffused in nature. Okay, little diffused in the nature, and hence they cannot overlap effectively as that of nitrogen. The p orbitals of these heavier elements are very large and they are in diffused state, so that they cannot overlap like nitrogen effectively. So nitrogen, since it is having smaller size, the p orbitals of nitrogen can easily overlap. Okay, since it is easily overlapping, it forms the effective p pi bond, p pi multiple bond. So this is the reason why this nitrogen is exhibiting as N2. Okay, so this is the reason why nitrogen is existing as N2, that is a diatomic molecule, whereas phosphorus, arsenic, antimony and bismuth, they cannot exist as diatomic. Understood, students? Next important one is why nitrogen does not show pentavalency. See, actually the maximum covalency of nitrogen is restricted to 4 and it does not show pentavalency. The reason is because it does not have vacant d orbital. It's not having d orbital at all. See, only 1s2, 2s2, 2p3 and it is not having d orbital. At least it should have an empty d orbital like that of phosphorus. But this nitrogen is not having empty d orbital even. Okay, that's the reason why it's not showing pentavalency, since it does not have a vacant d orbital in its valence shell. Due to this, this nitrogen cannot form p pi. What is this? P pi d pi. Okay, p pi d pi or d pi d pi multiple bonds. Okay, so these two formats are not possible. These two type of multiple bonds are not possible in case of nitrogen due to the lack of d orbitals. Okay, due to the lack of d orbitals, since it is not there, it is not possible to form p pi d pi or d pi multiple bonds. That's why this pentavalency is absent in case of nitrogen, whereas it can extend its covalency till 4. Understood, students? Next important one is why nitrogen shows no tendency towards catenation. Why it is not showing no tendency towards catenation. See here, this obviously this nitrogen is having a low atomic number, that is it is having a small atomic size, and obviously this is single N bond. Okay, nitrogen, I told you it is a diatomic molecule, so this single N bond is weaker than the single N bond present in phosphorus. Okay, and this is due to the high interelectronic repulsion of the non-bonding electron, that is lone pair of electrons. Okay, so lone pair of electrons are present in nitrogen. Okay, lone pair of electrons are present in nitrogen, and there will be high interelectronic repulsion existing between this lone pair of electrons, and because of this, this bond will be very weaker, which is due to the small bond length. Hence, catenation is not possible. Understood, students? Let me explain once again. See here, the single N bond is weaker than the single N bond of nitrogen is weaker than the single PP bond present in phosphorus, and this is due to high interelectronic repulsion of the non-bonding lone pair of electrons. So, which is due to the small bond length. Hence, catenation is not possible. Understood, students? Well, fine students, I hope you might have understood what I have taught today. Let me meet you with another important topic in my next session. Until then, it's Dr. Anita Rajua, Chemistry Mentor, signing off from you. Thanks for watching.